Hey, eighth grade. So this week we're going to continue talking about experimental design. And we're going to just start with a quick overview of the scientific method. The first thing during a scientific method is that you need to make an observation. After that, then you create a testable question. And usually this is written in the format, how does the independent variable affect the dependent variable? From that, you can then make a hypothesis, if, then, because, design an experiment, analyze results, and then come up with a conclusion based on those results. This usually relates back to the hypothesis. When you do an experimental design, you need to actually test the hypothesis. It also must have a control group so that you can compare the other groups to it. On top of a control group, you also need control variables, and these are all other things that stay the same. You also must have repetition so that the experiment can be validated. So you need to do this over and over again. So you have multiple trials to show that the same trends continue to happen. When we talk about a control group, we're talking about a group that stays the same so that all other groups can be compared to it. So for instance, if you were doing a fertilizer experiment, would be the group that wouldn't receive any fertilizer at all, or what we call the no treatment group. When we talk about control variables, we're talking about all the variables that you aren't testing that need to remain the same. For instance, if you were doing fertilizer effect, you would want the type of plant, the water, the sunlight, the soil type, all to remain the same. So basically, you're controlling anything else that could potentially influence the dependent variable as well, so that you know that that is not the reason for the change. When you analyze results, during this step, you're actually looking at the numbers in your data table and creating visual representations. So graphs, you're running statistics. And in this part, you're actually just simply stating what the numbers say. So you could say this one grew this much, this one grew this much, but you wouldn't imply as to why. Once you are concluding, this is the part where you then interpret your data and you can make inferences about why. This is where you can make those interpretations, make suggestions for future research, as well as explanations for what the data says. So why do you think fertilizer A grew more than fertilizer B? And you could say it has more phosphates in it or something like that. And that would implicate or be an inference as to why. Go ahead and move on to the questions. Once you're done, there's review questions on exit ticket for you to work on.